Alloy steels, tool steels, metals used to make tools and dies for cutting, forming, or otherwise shaping a material into a component or part for a specific application. It is designed to provide wear resistance and toughness combined with high strength. High carbon alloys. Properties: good toughness, good wear resistance, very good machinability, slight change of form during hardening, little risk of cracking during hardening, resistance to softening on heating, resistance to decarburization. Alloy steels, tool steels. This page shows the composition of some common tool steels. Alloy steels, tool steels. This page shows the properties and applications of tool steels. Tool steel properties: toughness, maximum hardness, heat resistance, wear resistance, machinability, deformation during hardening, hardening temperature, resistance to decarburization, and it also tells about the applications of tool steels. Alloy steels, tool steels. Widely used high speed tool steel is 1841 HSS, 18% tungsten, 4% chromium, 1% vanadium. It is considered to be one of the best of all purpose tool steels. The cobalt high speed steel is also known as ultra or super high speed steel. This steel contains 20% tungsten, 12% cobalt, 4% chromium, and 2% vanadium. Molybdenum steels, M steels, tungsten steels, T steels. Alloy steels, HSLA steels, high strength low alloy steels. Micro alloyed steels are low carbon steels containing small amounts of alloying elements. Weight reduction through increased strength. Widely used as structural or constructional alloy steels. High yield strength, good weldability, and corrosion resistance are more desired for structural applications. These low alloy structural steels have about twice the yield strength of the plain carbon structural steels. Manganese, silicon, niobium, vanadium, etc. may be added as low percentage level to increase the strength. About 0.20% of copper is usually added to improve corrosion resistance. Alloy steels, HSLA steels. This page shows the grouping, chemical composition, and strength properties of the high strength low alloy steels. Alloy steels, high strength low alloy steels. Characteristics of high strength low alloy steels: very high yield strength, they can be welded without becoming brittle. Very light, high corrosion resistance, good ductility, good machinability, good formability. Applications of high strength low alloy steels: structural members, weight saving is required, bridges, towers, columns, pressure vessels, automobiles, trains, etc. Alloy steels, maraging steels, low carbon, high alloyed steels, very high strength materials. Composition: nickel 18%, cobalt 7%, carbon more than 0.05%. These compositions develop martensite upon cooling from the austenitizing temperature. The ductility and toughness of this martensite result from its very low carbon content. High nickel steel, because of the predominant of nickel, considered as high strength alloys rather than as steels, since carbon does not play any part in developing the high strength. Alloy steels, maraging steels. This page shows the composition and mechanical properties of typical maraging steels. Alloy steels, maraging steels. Characteristics of maraging steels: very high tensile strength, impact strength is high, superior than conventional alloy constructional steels, very suitable for surface hardening by night riding. They can be welded. Applications of maraging steels, flexible drive shafts for helicopters, barrels for rapid firing guns, die casting dies, extrusion rams, space vehicle cases, etc.